This question is about rates of reaction. Figure 1 shows apparatus used to measure the rate of reaction when acid reacts with an excess of solid sodium hydrogen carbonate. When different monoprotic organic acids are used, the rate at which gas escapes can be used to compare the strength of the acids. A timer is started when the NaHCO3 is added to the acid and the mass of CO2 gas lost is recorded at regular intervals. It is assumed that any change in mass is due to the loss of CO2. Suggest a reason why a conical flask instead of a beaker would give a more accurate result in this experiment. So we use conical flasks when we don't want to lose our contents of our container. And that cotton wool in the top, that's about allowing gas to escape but not allowing the liquid to escape. And the conical flask just adds to that. It reduces the loss of liquid from our flask. Figure 2 shows the results of this experiment when 25 centimetres cubed of 2.23 mole per decimetre cubed ethanoic acid reacts with an excess of sodium hydrogen carbonate. Use figure 2 to calculate the rate, and rate on a concentration time graph is the gradient at 2 minutes. So I'm going to put a little mark at 2 minutes. I need to draw a tangent to the curve at 2 minutes. Okay, so we're going to take a ruler and put it on the curve and draw a tangent to the curve. So we're at 2 minutes. We want to sort of sit that like a contact lens on our ruler, so equal either side. And it helps to sort of pull your ruler both directions and see whether you feel like you are doing the same thing either side of the ruler. And then you want to draw a line along your ruler, so a tangent to the curve there. And then you want to make a triangle out of that wherever's convenient so that you can measure the gradient. So I'm going to use this line here. And then I'm going to make a triangle to it at some point. So I could go all the way back to there. It's in between two lines, but at least it gives me the x-axis value quite easily. Okay, so my y values 2.6 minus 1.15, and my x values is 3 take away nothing. So on our calculator, I divide that by 3. And I'm getting 0.48 from my calculator. Now, on the mark scheme for this, you could have anything between 0.45 and 0.55. And the units, well, we have to take the units of the y-axis, which are grams, and divide by the units of the x-axis, which are minutes. So it becomes grams minutes to the -1. The next part of the question says chloroethanoic acid, which would be Cl, CH2, COOH, is stronger than ethanoic acid, CH3COOH. Sketch on figure 2 the curve that you would expect. So we've got the same volume and the same concentration of a stronger acid. So we want our curve to flatten at the same point on the y-axis, so at the same 2.4 centimetres cubed, but we need to get to that point faster. So just try and tidy that up a little bit. So we want to be steeper, but end at the same place. And we're ending at the same place because we've got the exact same number of moles, same volume and same concentration. It's steeper because it's a more concentrated acid. And then suggest why chloroethanoic acid is a stronger acid. So the Cl is electron withdrawing because it's a more electronegative atom. So it has a negative inductive effect. So this, if you think about that, it's pulling electron density back, and it weakens the bond between, so if I put the bond back in, the bond between the O and the H. Allowing H plus to be donated. It also stabilizes, because it reduces the electron density of the O minus, stabilizes the COO minus group, and so it's less likely to reprotonate. It's less likely to reaccept the H plus.